Hi everyone, it's Crusoe here, and I'm back with the second part of the explanation where I actually explain the display itself. If you wanna make sure you understand, or if you're not good in all these memory cells and all that pulse and stuff, pulse health signal to pulse signal conversion or whatever, then watch the previous video. I will put the link in the description. So how this thing works, it looks crazy, this looks complicated first, but it's really not. So the first thing is, notice that I built a 13 display. Basically I just built one and then I copied it, and the red lights here represent the tens, so this the blue lights represent the ones, so this here means 73, this means 73, 73, 70, 69, 71. So I can tell you 7 days ago my accumulator went down even to 69%. 42. 9 days ago I had a crisis here almost, but it's still okay. I still had for that's when I probably built a new smelter or something, the steel smelter, I guess. Where is the steel? I just upgraded the steel smelter with modules and stuff. The reason the robots are so slow because I have the game on half speed. Yeah, I can actually put the game speed back now to 1, so you can see it in, see my robots are how fast they are. Okay, so how this thing works. So first let's start with in here. In the bottom here I just have a display. Actually over here I can explain the display itself. So that how the display works. Now the display gets a value called M, which is here 76, as you see. Now the M in here is is accumulator charge -1. The reason for that is because I'm reading the accumulator charge over here. This thing is very noisy. So I'm reading the accumulator charge here, but I also add 1 extra over here, as you see. So basically when my accumulator level is 100, it's showing 101 on the wire. The reason for that, because when I was starting to build this thing, I wasn't sure if I want zero signal. If I want to compare numbers, I'd like to have at least 1 signal, and at the end, before I display on the put on the display, I can just subtract that 1. So I wasn't sure if I need to guarantee that my signal is, actually I needed to guarantee that my signal is at least 1, because if I compare two numbers, like I compare A and B, if A is smaller than B, then I want to output A. Now if there is no A, then there will be nothing output. Now if I multiply 0 by anything, it will stay 0. It still might work, but I wasn't thinking, I just wanted a signal anyway. So I've added an extra accumulator charge, and I'm reading the accumulator charge. Now that then goes to here, and so that will just, this guy just converts it to negative, to M -1. It takes out 1 and then it just converts to M. Now this is I don't know, this may look complicated here, but it's really not. The M signal then goes to here. What is it? M signal then goes to here, which divides it by 10. That turns to N. Now the N is just going on these lights here on the bottom. So if I have the M75 divided by 10, it's 7.5. Obviously it's rounded down, so it will be 7. And so their 7 lights will show up. If these are set to N greater than 0, 1, greater or equal than 1, it's light up, greater than equal than 2, light up. It's the same here, just always one higher number, and this one is 3, 4, 5, etc. So they're all the same. Now only thing I do here is I divide this by 10, output n, that's the tens go on this display, and then the same m is connected to this display, and the n from here, the tens, for example, when I said 75, it will be 7, m 75 by divided by 10 will be 7, n equals 7 goes to the top here. It's connected, maybe you can see this wire, and this guy then hold on, yeah, this guy, no, the n doesn't go here, the n goes from here goes to here, which then multiplies back by 10. So if n was 7, it's multiplying back, so it will 70, and it will be d, which is the, I just said it, difference or whatever, I just don't know why I called it d, and the d connects to the top one, and the m from here also connects here. I actually don't see the reason to have this wire here, because it's going from here and here as well. So the m, which is the total charge, and the d is, which is the tens, are subtract from each other, so we get the ones. It's kind of simple. I don't think I should display. If anyone wants to ask me in the comments, I can do a better explanation. So this is just the display, the numbers. But basically, if you go and just move your mouse on these memory cells, you could see already this one stores 75, 73, 73, 73, 70, 69, 71, 69, 67, 42, 44, and 50. So 13 days ago I had really big usage of electricity. Okay, now, so how this thing works. So come back to, so this display in the bottom just shows the actual charge, so it's nothing to do, I added this later, it's nothing to do with the display itself. This is the actual charge. So as you see now, it will drop, it will keep dropping. I can just move my mouse on here, it's 99 now, so in here you see 99, that's the actual charge. Okay, so how this thing works, well, I just prefer to do this daytime because of the sound of this might be annoying in the YouTube video. Okay, so I have to wait a second. Anyway, I keep going, hopefully that noise will be not very annoying. So the accumulator charge is coming to this two combinator here. As you see, there are two decider combinator. One is set to greater, the other one is set to smaller or equal. Now, even before I knew what will be the name of the signal, I just called it M as the minimum, or yeah, minimum. So if M is greater than, I didn't know what I'm building, I just started to build here. If M is minimum is greater than an accumulator charge, then which one is the minimum? The accumulator charge, because it's smaller. So I output the accumulator charge. In the other one, if M is less than equal than the accumulator charge, then they are equal. It doesn't matter which one I use. But if it's less, I have to use M. So M is the smaller. So I'll put M. Now, the next combinator then, whichever signal comes, it can, we don't know yet. It can be accumulator or M. The smaller one comes out on this red wire. Oh, I forgot to keep showing you the wires. So accumulator comes here to here, and then from here to here. Okay, and then this guy, we don't know it's M or accumulator. We have to change the signal to something we know. So I just multiply by 1 each signal, whichever signal comes, and change it back to m. Now this m is the actual minimum right now. It's 74 right now. It's always one more because it's 101 here, as you see, because I've added an extra 1 here to make sure we have a signal. So in here it's 101, which means it's fully charged right now. Now that signal will go up to this memory cell. As you maybe see, it's how familiar is to the one I explained in the previous video. It's two combinator here, both equal, set to something equal 1, output everything. In this case, instead of X, I just use the R as a signal. Doesn't really matter. So the data comes to the top one, and then there's a green wire here, so it's the same exact, let me show, give me same exact layout that we had in the other video. If you don't understand, just look back. There is the output of that connect to the output and the input of this one, and we have a green signal to set up the memory coming from somewhere. I didn't explain that, but we have a green signal, a pulse that's coming from up here. Actually, we will see that later. So the same thing, and the data I forgot to show. The data comes to here, so there was the memory again, and the data comes to there from here, and so there was the oh my god, this I just noticed how big is that guy. So the pulse that sets the combinator comes from here to both inputs, and the data comes from here to only here, and then the memory cell is just like that, connected the output here to the input. So we have to make sure we have a double pulse here to set up the memory cell. Look, I'm referring again to the last video. Okay, so what's happening here is, oh, I need my mouse back, cursor back. So because I've added one accumulator level here to the data here, I have to add a -1. In this case we converted it to M, so just to make sure the proper thing goes on the display. So if it's 101 now, into here is only 100 coming in. Of course this is just the input of that cell, so it will not show the 100 here. It will set by the pulse here, which I explained in the last video. So then what's happening here, I had to make sure that this the data from this memory cell gets loaded to the next memory cell before I give the new data. And how I give the new data I will explain in a minute. So that basically before this bottom display shows the last night, and before I update that I have to move the data to the next memory cell. But before I move this data to the next memory cell, I would lose this memory cell, so I have to make sure I move that to the one above, and so on. So I have to make sure before I start loading the data from the bottom of this queue, I have to move everything up. So I have to kind of start on the top. So what I do here, let's say, I think whoever understands the combinators already know where I'm getting. So from this memory cell here, let me just give a color that we don't use, I don't know, yellow. So from this memory cell here, I have to move the data to the one here, and then from here to here. So this is the first step, this is the second step, this is the third step. Oh my god, very ugly drawing with the mouse. So how I do that is I have a pulse coming in from here, a double pulse from that electric pole to set up this memory. Okay, the data then comes from this combinator to this, but because if I use the R, if I use every memory, I use the different signal like R, A, B, C, D, any signal. But because I use the same signal, I want to make sure the data passes here, but not the set signal. So if I just show this guy here, this combinator only lets the data pass, so m greater than 0 can pass. So if I again try to draw this for you, the data, oh, I should move this out my face. So the data comes from where is it? You know, the data, oh, get me a bigger one. You know, the memory cell, if you remember, they are like built like this. So the data is on the red wire. I'm not connecting straight to the next memory cell, but I put this between, and I could use it from here, would make more sense, but I just put the wire here, as you see. Maybe you see. So that's how it connects. That's how each memory cell, I could even zoom out, but then my drawing will not match. Anyway, I think you could see it. I tried to do a quick one again. So oh, let me get my biro. So there are the memories, and there was one, I could see there was one update. So the data comes from somewhere there to here, and then here to here, and then here to here, and then here, and then from here it goes to the next one, and then here, and then the last one. So basically the memory is jumping up, is the data, I'm just showing the data right now, the data lines where the data goes. So the data from one memory jumps to the next memory, but I put a separator decider combinator between. Now comes the pulse. Now the pulse, let's say I don't know how I'm gonna start the pulse yet, but I have a double pulse coming up to set up the first memory cell. I will explain that later. We jump there in the next. So let's pretend we have a double pulse coming on this pole. Now this double pulse, this is the funny part, comes on this pole, sets up this memory. So it reads the data from the previous memory I just drew in a minute ago, sets to this memory cell. But I want to set the next memory cell a little bit later, 2 pulses later, because we need a bit time to write this memory cell. It takes 2 cycles. So at the same time I'm sending this to here, and this combinator is very simple. Let me show. R will be the pulse, R greater than 0, output R. So they are all the same in here in the middle. So I put the R into that combinator from at the same time when I start writing this memory cell, but to delay it by 1 frame, but I want to delay it by 2 frame or 2 cycles. I keep saying frames and cycles, it's the same thing. So this one delays it by 1 cycle, and then it will put in here, and I think you can already see, and this one delays it by another cycle, and then that's gonna write the next memory cell, and that's gonna trigger the next set of delays, and that's gonna write the next memory cell, and that's gonna trigger the next thing to delay, and maybe if I started with a bit zoomed out, I could draw it a bit longer. So trigger the first memory, at the same time start this, triggering the second memory, and then delay it, triggering the next memory, and then delay it, and then trigger the next memory, and then delay it. So that's how the R signal actually goes, and it keeps going 2 cycles later to each memory cell. It's passing through these combinators, which are just set to R. It could be anything greater than 1 pass, or I just set to R greater than 0 pass. I mean 1. I said 1. I meant 0. So the delay is there to set up the memory cells one by one, and we're moving the data from the second on top to the top. So from this guy the old data will disappear, and then from here goes to here, from here goes to here, and always from the previous level it's going upwards. And okay, and then we just need to get that pulse. And if you watch the last video, maybe you have an idea how I've made it. So I explained the minimum here, except these little combinators here I didn't explain yet, because they are the reset signals actually. So what we doing here is, this is how I'm sending the first pulse. If you watched the last video, I showed you how to make a health signal, how to convert a hold signal to a pulse, or even to a double pulse. And that's what exactly happens here. The accumulator level, when it gets to 101, which is a full charge, you remember I've added 1 here. So when it gets to 101, we send the R signal out. So in this combinator, the R pulse basically, which is not pulse yet, it's a hold signal. So that goes to this combinator here on the top, which sends out the first signal here up to that combinator, or first to this pole and then to that combinator, and then it's delayed by 2 combinators here. I actually think 1 is enough here. What did I do here? Okay, the first, I actually think, yeah, this top one is not really required. I could just connect. Let's simplify this. So why I have that? Yeah, this top one is not needed. I could just do this. Okay, I think it's the same thing. So this one outputs the R in here, and the first cycle, this one outputs straight on the pole, and then also at the same time outputs to a new combinator just to delay it by 1 frame. And then so this, when the R presents on the green wire, it will be at the same time, it will feed back to the second combinator, and then that 1 frame later will multiply it by -1 and come back here, and then this guy only lets the positive numbers pass through. If you watch the last video, you understand I explained that there a couple of times. So when my accumulator is charged to full, that's when I'm gonna set that's when I'm going to move the data up by 1, because I think that's when I know the accumulator level will not go any lower, because we are actually charging up. I be charged up fully. And at the same time, when all the memory is written, which is going on these pulls on these combinators here on the right side. I just explained that. So it's going down and down and down, and at the very last moment actually we can use that to reset the minimum. And what I'm doing here is R is greater than 0, it passes, so we just waited 1 more second to make sure this all the memory cells are read or set. And I'm doing here if R equal 1, so when all the memory cells set and the R is equal and the pulse is down here at the very bottom, then I'm gonna let pass M on this combinator, and the M from to that combinator is coming from here, and it's 100. So when the accumulator will be probably already charged to 100 anyway, but the M will be still showing the last day minimum, so it could be 44 or 72. So I have to change M to a high number to make sure. Probably M will be 52 or 70. What is this now? 74 M. So if M is 74 and this green wire, red wire here, which is comparing, if I add the 100 to it, 174, I made sure that I have a so high number that the accumulator is 100, so it will set to again to 100. And then during the day or during the night, it will keep going down to the lowest, to the minimum, or this guy will keep storing the minimum, which I explained earlier how to make. And this is it. I think I finished explaining the whole thing. So I hope you understand, you enjoy. If there's any comment, just put on the video. I try to put the blueprint, and maybe I make a playlist of this, add to this playlist, and I hope I will have time to make more videos for the future, more tutorials and explanations. And feel free to use this guy in your factories, or maybe make it more simple. The display probably could be different, and it's all up to you now what you do with it. I hope you've enjoyed. Bye bye.